2x cubed plus 4. The derivative of 2x cubed is 6x squared. So this is the link you're looking for right there. You've created that link. Here's that x squared and here's that x squared. So does it matter if you call it w or u? Does it change the math? You call it Bob if you wanted to. It doesn't matter. You do that, and then you have to take care of that 1/6 because there's no 6 there, and everything cancels nicely. The order you've done several times so far is you choose a w. So what do? You choose a w, and then what do? You substitute, integrate, and then you substitute again at the end to get the final answer. So on this one, you took the derivative, and then you ended up with this right here. You ended up with 1/6 dx is 1/6 du is equal to x squared. So that ended up right here. And then the u, I'll use green here, this took over for this right there. So then you integrate and you resubstitute. You integrate and you resubstitute. I'll ask you this. When you're looking for a w substitution, you're looking for a function whose derivative is there, or some multiple of a function. You're looking for something where when you take f, you're looking for something where it's like a constant times f prime is also there. When you look at this, is there any function whose derivative is there? No. So in this case, this is just the expand and simplify method. This is just expand and simplify, because you end up with this. And can you integrate that really quickly? Yes. So this is the expand and simplify right there. That's it. So the question is, do you see something whose derivative is also there? That's what you're looking for. If you don't see it, try rearranging it, try simplifying it. You have to simplify it all the way, all the way. Integral, are these definite or indefinite? Definite. These are definite integrals. These are definite integrals, that is correct. Why are they definite integrals, Jen? Why are these definite integrals, Jen? Integration, therefore they are definite integrals. So we can do these because we know how to plug numbers in and we know how to do w substitution. So on these two, you actually need both of them, both of those things that we know how to do. So what do you think w should be on this one, Jen, the first one? Let's just stick with the first one. What do you think w should be on the first one? Yeah, x squared. Why did you choose x squared? Yeah, it's there, so it'll cancel. Yeah, hopefully, right? So you've done this a bunch of times, 2x dx. So you have dx is equal to dw over 2x. So we've chosen our w, and now we substitute. So when we substitute, we end up with x e to the what power? X e to the w, and instead of dx, we have dw over 2x. And what's that nice thing that cancels? Yeah, the x's cancel, and then what could you factor out to the front, Jen? 1/2. Yeah, 1/2 integral of e to the w dw, and that's about as nice as it gets because the integral of e to the w is, yeah, so you have 1/2 e to the w plus c, but now we need to substitute back in. What does w equal? So it's e to the x squared, and we don't need the c anymore because in definite integral land, what is c minus c? What's c minus c? 0. It drops. So we're integrating this from 0 to what? 0 to 2. So if you plug 0 and 2 in there, you have 1/2 e to the 2 squared minus 1/2 e to the 0 squared. What's 2 squared? 4. E to the 4th minus 1/2 e to the 0. What is e to the 0? 1. So you have 1/2 e to the 4th minus 1/2. Now, if you stop there, that is totally fine. There's only one other form that people might write that in. What's the one thing people might do to this to make it, quote, look better? You could make it e to the 4 over 2, or you could factor something out. What could you factor out? So some people might write it like this. The AP test loves to write things like this, for example. Both of these are the same. Either one is fine. You will notice in my work, I stopped writing something almost immediately when I started work on this one. What did I stop writing? I dropped something in the second and third lines. What did I not write? I didn't write the limits for a very specific reason. Does anybody know why I didn't write the limits in? What kind of values are 2 and 0? Are they q values? Are they p values? What are they? These values, 2 and 0, what type of values are these? These are what values? They are x values, right? Once we got to here, do we have any x's in there? We don't. We only have what values? We only have w values. What's in the upper right there, Henry? What's the relationship between w and x? What does w equal? So w in terms of x is x squared. So what is w0? When you plug 0 in, what do you get? 0. What about w in terms of 2? What is that?
4.
So 2 squared is 4. So if you want to write limits of integration in, this is in terms of w, so therefore you can't put x values as your limits of integration. What do you have to put in? So you could put 4 and 0, and here's why that's really helpful. Look at that red box right there. If I just gave you this on a test, Jen, if I just said, or anybody else can answer this one because you've answered a whole bunch today. If I just gave you this, the integral from 0 to 4 of e to the w dw, if I just gave you that right there, can someone integrate e to the w for me? What is it, Zach? What's e to the w? Integrate it. Yeah, it's 1/2 e to the w from 0 to 4. Oh, what's that? 1/2 e to the 4th minus 1/2 e to the 0 is what? 1/2 e to the 4th minus 1/2. Hey, is that the same thing we ended up with before? Is that the same exact thing? So either you get to substitute here, or you have to do a little bit more work here. Which one seems a little quicker, the green path or the black path? The green. You do a substitution, but look at this substitution. Do you like this substitution right here? Probably. Let's try it up here. What's the w going to be, Gabby? What's the w on this one going to be? Yeah, and this is a little tricky. What's dw dx going to be on this one? What's the derivative there? Yeah, just -1. Exactly. So dw is equal to negative dx. So dx is negative dw. When you do this substitution, be very careful. It's going to be the integral of 3 over w. And then what is it? Negative what? dw. We just do the substitution there. What have I not written in yet? What's missing still? What are these called? Limits of integration. What do we know w is? W is 5 minus x. So what's w1? What's w with 1 plugged in? 5 minus 1 is 4. And what's w3? 5 minus 3 is 2. So what do you write here? 1 turned into 4. And what did 3 turn into? 2. Even though 1 is greater, the bottom is greater than the top, is that okay? Yeah. Can you still plug those numbers in? Sure. Could you flip them if you really wanted to? You can, but what happens if you flip the limits of integration? It makes the whole thing negative, which is fine. Either way works. Leave it like this, though, because now, what can you factor out to the front? So you have -3, the integral from 4 to 2 of w to what power? W to what power? -1. Bless you. This one right here, integrate that for me. What it is? It's going to be equal to -3 times, what is the antiderivative of w to the -1? ln of the absolute value of w. Remember that, everybody? We've done that a bunch. And you're evaluating from 4 to what? 2. So what's that going to be? -3 times ln of 2 minus ln of 4. Everybody with me so far? You can stop here. This is fine. I'm okay with you stopping there. I need you to pause. Minus means in logarithm land. Anybody remember? Division. So this is -3 ln of 2 over 4. What's 2 over 4? 1/2. That's 2 to what power? 2 to the what power? Come on, you can do it. -1. What can you do with that -1 power? Anybody remember what you can do with that -1 power? You can take this and you can bring it to the front, so it turns into -1 times -3 times ln of 2. What's -1 times -3? That's 3 ln 2. So logs are entertaining because you can make things, these are totally okay, but I'm okay with you stopping at the green. I'm okay with you stopping at the green, but I wanted to make sure you saw that because you need to be able to do that if kind of asked to do it. Okay, so let's take a look at a different one here. Here's a fun one. This is an awesome one. W should be on this one. Just take a wild guess. 4 plus 2 e to the x. You want something that's cleans up when you take the derivative. What about this one? What do we think the w should be on this one? This is pretty hard. I don't know what the W should be on that one. Anybody want to guess what they think the W should be on C? Any guesses? Choosing a W value. So we've chosen 3 already. We're relatively sure. Maybe C is a little challenging. But on this one, when you're choosing a W value, what's the thing you're looking for, Nick? When you're choosing a W, what are you looking for when you choose a W? You're looking for a function and its... Exactly. So when you look at this, do you see a function and its derivative anywhere? No. So remember, what's another method you could always try doing? Expand and simplify. So on this one, what I mean by that is, I think Henry asked this before, we did an example like this. Do you need W substitution to do this one? No. Maybe not. You might not. So try this one by yourself, but don't integrate. Simplify that first for me. Expand it and simplify, and then stop there. Means what? Division. So theoretically, you could write this as what? 12 plus ln of 5 over 3 if you wanted to. It's the same thing. It's the same thing. I'll give you a hint. Whee! Yeah, what'd you say? Perfectly said. Distributing the negative. They write out minus and then they don't do the parentheses, and it causes a cascade issue.